Hi, my name is Mary Jean Schmelzer Hoekstra, and we're here today to talk about probably the most urgent structural problem facing our congregation as we move forward, and that is the sinking of the activity room. For some years we've known that we had a water problem. We thought we had a marine clay problem. We have now looked into the soil underneath the activity room and find that we have not only a water intrusion problem, but that the water that's under our building is literally washing away under that building. You will see evidence of this as we go down and look at the cracking on the sides of the building, and perhaps we can see some indication of where the building has literally sunk into the grass. Okay, if you look at it here, you can see how steep the hillside is and how much of that is flowing right into the edge of the activity room. According to our architect, we need to move that hillside way back and exponentially increase the amount of drainage we have around the building. Now we're inside the activity room looking at the hill. Notice how close this hill is to us and how steep it is, and how high this drainage area is relative to our windows. This indicates water intrusion. This is efflorescence, which is I gather it's a calcium that forms on the outside of buildings. That's why we have weep holes. But when the water is not flowing out, it calcifies, and we have the beginnings of our own stalactites. Again, you can see right here the amount of water. It's not raining right now, but you can see the stone is retaining this water, and the water is not going elsewhere. It's sticking right there in the building. So some of our strategies to get rid of this water are not working that well. This is just a standing wall. There's no building next to it, so there's no heat on the inside driving out the moisture. So even though we've just cleaned this, the efflorescence is coming back very quickly in this area. We're right immediately outside the activity room, and we're on the corner that has had the most subsidence over the years. You can see the crack at the foundation level on this brick, but you can also perhaps see that the building itself has sunk considerably below what would have been this full brick right here. We're standing in the activity room. This is part of the addition, which was completed in about 1994. The architecture committee has been working with an architect for the last year or so, and we have hired a firm that was exceptional in its engineering abilities, and in particular we have found that their expertise in this area is very helpful, because we have done a lot more study of the soil strata under this building, and we have learned that we do not have a marine clay problem. We actually have an erosion problem of the soil underneath the building. The architect has informed the committee that we have essentially a couple of choices. In order to fix the problem, we will need to remove the stone, the brick that's on the outside of the building. We will need to cut the hill back, redo the drains. We will need to excavate in such a way that we will firm up the foundations. Then we can either put the building back exactly the way it is now, and it will be dry and it will be reliable, or we could choose, if we so choose, to to build on top of the building, provided that we rebuild the foundations in light of that weight and whatever design we want. We could also theoretically expand the footprint a tiny bit, but not very much in terms of what the county setbacks permit. The prices for this sort of work will be ready for the congregation, think about, probably by June.